In this session, I am going to talk about the real number system. The system of real numbers consists of a collection of smaller sets of numbers that has evolved over several centuries. It began with numbers used to count objects, which were used for trading. It was then extended and refined as a need for numbers to represent parts of objects, and locations on the number line became important. Below is a discussion of the sets of numbers that make up the real number system. Each of these sets builds on those contained in the preceding sets. First of all, I'm going to talk about natural numbers. So, natural numbers can be thought of as counting numbers. So, for example, counting numbers we can write like this. We say that the set of counting numbers C, and then we never count from zero. We count the counting start from number one. So 1, 2, 3, 4, so on. So those are counting numbers or natural numbers. So the second one is whole number. So whole numbers consist of the natural numbers with the addition of the number 0. Now, for example, the set of whole numbers is W. We can write like this, starting from 0 to 1, 2, 3, 4, and so on. So we call this whole numbers. And the next one is integers. The sets of integers builds on the set of whole numbers by adding the negative values of each. So integers we can represent on number line like this. So you know the number line middle is 0. On the right side we can write plus values. On the left we can write negative values. Plus 1, 2, 3, 4, 5, 6. On the left we can write down now negative 1, negative 2, negative 3, negative 4, and negative 5. So set of negative number in set of so integers we can write negative values, 0, and the positive values. So set of integers we can write down as I, and then we can say negative 3, negative 2, negative 1, 0, and 1, 2, 3, 4, and so on. So the next one is the rational numbers. So the rational number is any number that can be written in the form of A over B, where A and B are integers and B is not equals to 0. So any numbers, if we can write A over B, where A and B are integers, as well as B is not equal to 0. So for example, we can write down 8 divided by 2. So this is a rational number, but if you write down 8 divided by 0, we can't write. This is not a rational number. Why? Because 8 divided by 0 reaching to infinity. So it's not defined. So we can't write like this. So examples of rational numbers. Any fractions or improper fractions are rational numbers. Now see that mixed number 2, 1 over 3. 3 times 2 is 6, plus 1 is 7. So 7 over 3. I can write down this one as an improper fraction. Now we have numerator and the denominator. So this is A over B, and this is a rational number. And also all integers, sort of negative 11, negative 3, and then 68, any integers, because these integers we can write down. Negative 11 we can write as negative 11 over 1, or we can multiply both numerator and denominator by 2. We can write down as negative 22 over 2. So all are rational numbers. All integers are rational numbers. And also all terminating and repeating decimals, both positive and negative, are rational numbers. Now, for example, 0.8 is a rational number because 0.8 you can write as 0.8 you can multiply by 10. The denominator is 1. The same side you multiply by 10, and then on the top you have 8 and the bottom you got 10, and then you can simplify further. You have 4 over 5. So this is a rational number. And also 1 over 3 is a rational number. Why? Because see, when you divide 1 divided by 3, and how many 3's goes inside 1 is 0. 3 times 0 is 0. And 1 over 0, 1 take away 0 is 1. Put 0 here, put the dot. And then how many 3's goes inside 10 is 3 and 9. 1, 0, 3, 9, 1, 0, 3, 9, and 1, 0. It continues like this. So 0.3 is a pattern, and then it's 3 is repeating over and over again. And then is this also a rational number? And then look at this example, 7.12, and then 7.12 is never ending, is repeating. So I can write 1 2 as like this, and so this is a rational number, right? And then for example, square root of 13. So square root of 13 is 3.605513 is shown. And look at this one, is never ending, and also it's not repeating. We can't find any patterns over here. So therefore this is not a rational number. This is irrational number. Similarly, square root of number 2, square root of 2, square root of 2, also not a rational number. It is irrational number. So this one, 1.41412113. So it's, you can't see any pattern over here, right? And then also never ending. And then this is a irrational number, 2.333. Is this a rational number or irrational number? This is 2.3333 is repeating the same number, so we can write it as 2.3 is continuous like this, and then this is a rational number. And also 5.01000382. So this is never ending, and also is not repeating. So this is an irrational number. Irrational number. The value of E also irrational number, right? Value of phi also irrational number. Okay, let me summarize what we learn over here. So we have all the numbers we call real numbers, and then we have here rational numbers, and then also we have irrational numbers. So under rational numbers we have integers, we have whole numbers, we have natural numbers. So I hope that you understood this lesson. We can continue from next lesson. Thank you.